Okay, welcome to my talk about the Drone Economy 2.0, economic use by digital visualization. So maybe to start with, who of you has a drone at home? Okay, those are several. That's good. So what do you use it for? To take pictures or other applications? Well, I assume you're taking pictures with it. So in order to take pictures with the drone, there's no, well, you see it during all of the time, right? So you're not flying the drone further away so that you cannot see it anymore. So why do we need a Drone Economy 2.0? There are also application areas where you cannot see the drone with your own eyes anymore. For example, if I think of McDonald's delivering a coffee to people, or a bit less fancy, if you're transporting blood samples from one hospital to another, then you do not see, or the one controlling the drone pilot, does not see the drone anymore. So there's a need for a digital visualization, because if you're just taking pictures with your drone on holidays or for a wedding or for whatever, who needs digital visualization? But if you really have application areas where the drone is flying far away and you'll not be seeing it anymore, I mean, of course, you can put a friend every kilometer to observe the drone, but no one really wants to do that. So there is the need to see the position of the drone, and there is also the need to see other airspace participants, because if there is a helicopter hovering around and I'm hitting it with the drone, that's not so cool. So what's this Drone Economy 2.0 about? One really big application area for drones is transport. So I think everyone has heard of air taxis yet, so that's transporting passengers, but also freight, which is a bit closer to today. Drones are already transporting some goods to a certain extent. It might be a container like this, but it might also be smaller items, like I said, blood samples or Amazon packages or other stuff. So there's a huge potential on drones, because a helicopter is way more expensive. A helicopter is louder than a drone. So a helicopter goes on fuel. A drone is electronically powered or electrically powered. So drones have a huge potential, for example, for the transportation area. You can automate it. It's less emissions. There's a lot of potential for drones. But it's not only transport. It's also digital services like surveillance. So companies use drones to inspect pipelines, for example, or inspect railway tracks if there is a fire or if there's a damage on the railway tracks. Companies use drones to inspect the building of whatever, Terminal 3 in Frankfurt, or a skyscraper, so you can easily use drones to inspect the statues. And there are still more application areas. I could go on for a lot of time. Police can use drones to do search and rescue tasks. You can use drones to fly over a wood fire, for example, to see where there's fire and where there's not. You don't need to put a person into a helicopter to fly over the fire, but you can use a drone easily. So there's a lot of application areas, but all of those application areas are beyond visual line of sight. So the pilot of the drone will not see the drone while operating it. And yes, the potential is huge. As I said, there are a lot of headlines saying there are thousands of jobs to be created with drones. We're even speaking of a superhighway of drones. We have the eVTOL, so the air taxi, which is in the media very often. So there's a lot of potential, and also the media thinks that there is a lot of jobs, a lot of money behind it. But do we have that today already? No, we don't. The question is why, and it's not that easy to integrate a drone into the very low-level airspace, and I'll come to that later. So, as I said, there is an increase in the drone market. We think that especially the commercial drones will be used a lot more in future, but you need to manage them. So if there's a drone flying around at 200 meters and there's a police helicopter or a general aviation aircraft, that's not so good. I mean, they won't hit an A380. The A380 is at like 11 kilometers height, and the drone is at 200 meters, but there's still general aviation. So we don't want those accidents, we don't want those headlines, because then drone economy is going down pretty fast, we think. So we need a traffic management system for drones. And, well, the crucial part is the visibility, because do you see the drone? No. So you need to see it on a screen electronically. So, yeah, as I said, that this is limiting the potential of drones, because it's not that expensive buying a drone, operating a drone, but it's very time-consuming, bureaucratic to get the permission to fly a drone beyond visual line of sight. So if you say, oh, cool, I want to inspect my pipeline with the drone, I really have to undergo a process to get the permission to do so, because I have to make sure that the risk is limited. And the risk is I don't see the drone could hit anything, and so it's still a lot of bureaucracy, and we really need to do something here. And the key thing is making drones visible. So I'll show a small video on that part.
3, 2, 1, liftoff. Our technology turns a toy into a tool. One that integrates itself, that moves freely because it's controlled by a central system. Constantly connected, at every place, from every location. It collects valuable data, detects dangers, prioritizes the safety of others. Our technology takes digitization into the third dimension. Welcome to the future.
Okay, then we're back. Okay, so what's the idea? The idea is to have a UAS traffic management instead of an ATM, an air traffic management. So for the big airplanes, we have the ATM, and for the drones, we'll have the UTM as a management system. So the idea is that we see every traffic, we see manned traffic, we see unmanned traffic, we can give warnings if there's a conflict approaching, and we can still provide some more services to the drone operator to have a safe drone flight. Yeah, and how do we do that? To come back to the visualization, we put a transponder like a matchbox, it's called hook-on device. We attach it to the drone, and this transponder makes the drone visible and is using the mobile network. So the position of the drone is sent to our system via mobile network, and we know all the time where the drone is. So we get the position, we get the velocity, the heading of the drones, and we still add some other information like the operator ID, so we still add information of the operator, and this is information which should be provided to everyone using this very low-level airspace to make it possible to operate a large number of drones at the same time in the same airspace. Yeah, so this is how this UTM works. As I said, there is this LTE transponder attached to the drone and sending the position. This LTE transponder also has a GNSS antenna to get the position. The LTE transponder has a receiver for FLARM and ADS-B signals. Those are signals which are sent by airplanes. So ADS-B is more for the larger aircraft, and FLARM, it's flight alarm. It's for general aviation. So this transponder will not only send the position of the drone, but it will also receive traffic from the surroundings, because you need to have information about the manned aircraft operating in the very low-level airspace as well. So it's pretty nice. You get the information on like general aviation and airplanes in the vicinity, and you send the position. And a third thing, we need the LTE network, right? So how is LTE coverage in Germany? Yeah, that's it. So there's still a more sophisticated feature. We're still sending the position. So if there's no LTE, the drone is sending the position via flight alarm on top, so it can be detected by other airspace participants or by antenna infrastructure. Yeah, so this is an example about this hook-on device attached to a drone, and you see that you're monitoring the height during the flight and you're sending the position. So this way of visualizing drones electronically, it's called network remote ID. So the drone is sending a data set consisting of the velocity, the heading, the position. Then you still add some information on the operator, which is kind of a license plate. There is an operator ID everyone operating drones gets from the local, from the national authority in Germany. So this one is also sent. So in case anything happens to the drone, we have the license plate of the drone. So to say, yeah, and then you can track the position during the whole flight. You can also track other things. So, okay, I have to admit this is not a flight, this is a car trip. But anyway, you still get information which satellites are detected at what time, how is the connectivity. So you could also use this to measure the connectivity in a certain area and some other information. So this tracker, this LTE transponder is collecting a lot of data during the flight, which is also quite helpful. And then there is another way of visualizing, which is kind of for the public. So this is not called network remote ID. This is also not using the device I just showed you. This is another topic. It's called direct remote ID, and it's a lot of drone manufacturers have implemented that directly onto the drone because they have to until, I think, 2024. So every drone has to send the information, as I just told you, all the time via either Bluetooth or via Wi-Fi. So this means that in a few years, every drone will send information about itself, and then you can use an app similar like Flight Radar today. And if you see a drone, you can use your app and look into the sky, and the app will tell you what's the license plate, what's the operator ID, what's the heading, what's the position. So this is also pretty cool, and this will also, I think, do a huge impact on making drone flights more acceptable, because if I myself see a drone and I think like, I don't think that this drone is allowed to operate there, I can note the license plate and I can give it to the police and say, hey, I saw a drone there and can you please have a look? So this is visibility for the public. And for example, we as Dronic, we have an app which is collecting this information from drones and which is adding a bit like Flight Radar information on manned air traffic and information on all of the drones that we capture with our LTE transponder. So this is a way of making this, this air traffic situation also available to the public. Yeah, and then there is another important link for the electronic visualization, well, the ATM world. So I just said the A380 is operating at 11 kilometers height. It's not interested in drones. Yeah, well, but there's an airport, and there it comes down, and then, So we're working on that. It's not implemented yet, but we need to do an interface between the UAS traffic management and the ATM world, so the air traffic management, so that all the drones which are operating in the controlled airspace are also in some way, the information is transferred to the air navigation service provider. One big thing here is that, well, everything which is going into a tower, which is every information which is transferred to an air traffic, an air navigation service provider, the standards for this interface are pretty high. So it's not that easy to just say, we have a data stream, do you want to implement it into your systems? Then the ANSP says, yeah, well, it's quite a crucial thing from security aspects. But this is also an important thing because we have the vision that also in controlled airspace, it should be possible to fly drones if we make them visible and if we give information about every flight movement to the drone operator and the other way around. Yeah, so this is basically our vision. Our vision is a complete air situation picture, so we want to have all information about all airspace participants in one, well, this is a screen, but it's also, well, it's a data stream mainly, which can be shared with drone operators who can integrate that into their control station for the drones. And we think this is really the basic for empowering the drone potential, because otherwise we won't be able to fly a drone beyond visual line of sight safely if we don't have all the information about everything going on in the airspace. Okay, so this is nice, but there's always a but. There are several problems. So on the one hand, the drone operator needs to wear our hook-on device. Who will force them? No one. Who will say, yeah, cool, give me a device, it costs money, and I buy a service that costs money? No one will say that just like that. And also, the general aviation doesn't use transponders if it's not an airspace where it's mandatory. And it's most of the airspace that it's not mandatory to have a transponder. So there's no use of this if there are participants which do not, of the airspace, which do not make themselves visible. So it's nice if I have 50% of the traffic, but it's still dangerous because the other 50% is not in this picture. So what is the idea to make this mandatory for everyone? This idea is called use-space. There's a regulation from the EASA, the European Agency for Safety in Aviation, and this is an idea for airspace where I have a lot of movements in the low level. So this is an idea, for example, for cities or for control zones where I have a lot of air traffic going on and potentially also a lot of drone traffic then going on. And in this use space, there are certain rules. So in this use space, I say every general aviation has to make itself visible. And I say every drone needs to transfer the position. So yeah, this is quite the big thing in the drone business at the moment, this use space idea. It's also a bit of a competition between the European states, who's establishing the first use space and what it will look like. Because this regulation, it was, the date is like April 2021, it was published. And it becomes effective in January next year. So then it's the question, who has the first use space? Yeah, it's quite a prestige thing. And in this use space, you have several services which are mandatory. So everyone who is operating a drone in use space needs to use those 4 services, which are provided by a service provider, a use space service provider, which is kind of the digital air traffic service provider. So it's a bit the digital ANSP. The digital Deutsche Flugsicherung. So yeah, the idea of use space. There are several principles. As I said, it's an airspace where I have a lot of drone traffic expected. Then it's a limited airspace, and I have certain roles in this use space. I already said the use space service provider is one role. Then I have a common information service provider. This is kind of the single source of truth if it comes to geodata, for example. Yeah, and then the competent authority, which is the BMDV in Germany, so the Ministry for Digitalization and Traffic, also plays a role in that. Yeah, so what's this use space about? I'll talk a bit more about the services now. So in this use space, you have 4 mandatory services. I already said it. The one is the network identification service. So everyone who's operating a drone in use space needs to transfer the position. I think I explained it earlier. So everyone who's operating a drone in use space needs to send the velocity, the heading, the position, the operator ID, like the license plate, all the time when operating in use space. So for the drones, I see all of them, check. Then there has to be a traffic information service. So the use space service provider, the digital Deutsche Flugsicherung, gives information on every traffic in this use space. And with every, I really mean every traffic. So general aviation has to make themselves somehow conspicuous, so they can use a FLARM transponder, an ADS-B transponder. There's the idea that they use an app, which is sending the position over LTE. That's also an idea. So I see everyone, I see every drone, I see every manned aircraft. And then the fancy thing is I book a slot for myself. So in this U-space, I can load the 4D trajectory, so I can say I want to fly from A to B during this time. And then I can request a flight authorization for this, and I book a slot in the U-space for myself, and no one else can then reserve this slot. So this is pretty cool, I think, because like this, I'm sure that if I'm flying during that time from A to B, no one will cross my way, at least no other drone. So that's a bit the idea of the U-space, that I have a separation of drones by this flight authorization service. I still have to make way to the manned traffic, so that's the rule, manned before unmanned. So if I see with the traffic information service there's a police helicopter approaching, I have to make way. But on my authorization path, I know that there's no other drone operator during the same time. And then the last is the geo-awareness service. So we're also sharing information about all geozones. So, for example, about wind turbines or motorways or heliports or any other geozones which might affect my flight in U-space. So this is also good to know. And also, there might be temporary airspace restriction. For example, if there is an accident on the highway and the police says, okay, no drone is allowed to fly around like a kilometer off there, then the police can also tell the U-space service provider there's a limitation, and then they will close this airspace within U-space. Okay, so those are the services. There's a lot of data involved. To briefly sum it up, so there's traffic data going into this UTM. There's operation data about the drone operations. There is geodata, and there's the traffic data about the drones flying and the data about the operators flying. So there's lots of data coming together and being distributed to the drone operator, either via graphic user interface, which you just saw here, or also via data stream. And the idea is in future, or the vision, that with these services, drones can operate in this U-space pretty freely because they have all the information. They can maybe automatically evade all the traffic which is closed to them, and they have a predefined path, and they can basically be sure that there's no collision. So what's going to be important for that in the next year? So it's not as easy as it seems. So one thing, visibility of all aircraft. That's our vision. That's, I think, the basis. But what do I do if someone is not following the rules? There are drone detection systems. I somehow need to make sure that, yeah, I cannot do anything. If there's a glider and it's not using a FLARM transponder or any other transponder, that's bad. So the key thing is really that everyone's visible, but everyone has to agree. So you have to sell to the general aviation that so far they've been just flying freely and now they should use a transponder. Also not so easy. If you come up with rules later on you didn't have before, that's always a thing. So visibility of everyone is the key for making the drone economy fly, I would say. Then there's a huge issue with the legislation still. So I just talked about this EASA regulation. It's implemented, it becomes effective, but every member state of the EU has to put it in national law. Have we done that in Germany yet? No, because it's not so easy. You need to involve all of the stakeholders. It's really a complicated process, and every country needs to do that. So this will be a big thing in the next year, how the German interpretation of this will look like, how the German national law of this will look like. Yeah, then we have the importance of connectivity. Well, everyone knows the situation when being in a football stadium and everyone uses their phone and nothing works. So it's bad if this is the case in a U-space and the drones can't send the position. And there's not a lot of research yet what happens if a lot of those LTE transponders are flying. So the mobile network is made for using it on the ground. Of course, it can also be used in the air, but there's no studies about it yet. So we really need to keep an eye on that. Well, and then standardization is a big thing because we'll have a lot of data interfaces. So the interface between one U-space service provider and another it might be several ones in a U-space. There's the data interface between the U-space service provider and the operator, then between the U-space service provider and the common information service provider. Then there's still an interface with the air traffic control world. So there's a lot of data interfaces, and they really need to be standardized, because otherwise this concept doesn't work. And otherwise it's also not transferable from one European country to the other. So the idea is that U-space works a bit the same in every European country. So this is a big issue still to be addressed. And then what else do I have? Yeah, it's really, the automation is really important, because I don't know how much you know about how Deutsche Flugsicherung operates, but the DFS, like the Deutsche Flugsicherung, is talking to the pilot of the aircraft. I don't see the USSP talking to the operator of the drone, because there will be many, and there will be many drones, so this doesn't work anymore. So we really need to automate this. For example, at an airport, the air traffic controller tells the pilot he's allowed to land. For this U-space, for the authorization service, it will not be the case that the U-space service provider tells the operator that he's now authorized to do his flight. That won't work for the amount of drones flying around. So we really need to automate a lot in this world, because, yeah, drones are also flying automated, and there's no pilot in there, and the number is much larger. So there's still a lot of challenges, and that's also the reason why you can't order a coffee by drone today. But yeah, we're working on it, and yeah, I myself, I'm really, really happy to be able to shape the drone future still, because I said there's a lot to do, but this also gives you the opportunity to take part of that and to work on it, so that maybe in 2 or 3 years we see more drones flying around and they do really helpful tasks. And yeah, that's pretty cool. And at some point, we'll also have air taxis then. Yeah, so some last words maybe about Dronic, just to give you an impression what's our business in that. Well, we're a joint venture of the Deutsche Flugsicherung and the Deutsche Telekom, and our goal is to become such a U-space service provider. So our goal is to integrate drones safely into airspace. That's our business. Yeah, and that's also our mission and our ambition, to really make everyone visible in the airspace and make drones fly safely. Yeah, that's it. And thank you very much for the attention, and I'm happy to take questions if there are any. Just a short recap. Yeah, this is our game. This is our goal. That we really have this future where a lot of jobs are in the drone economy, a lot of revenue flows. That's also the goal, to make this happen. Thank you very much.